Hi, this is Mr. Beckstrom, and today we're going to do a sample problem from section 4.4. This is properties of rational functions. So here I have a problem. It says find the vertical, horizontal, and oblique asymptotes, if any, of the given rational function. So first of all, we have to understand what these are. So vertical asymptotes are vertical lines that usually the graph approaches from one or both sides. The horizontal asymptote is a horizontal line that's left to right where the graph usually approaches either one way or the other, sometimes below the line, sometimes above the line. And then the oblique asymptotes is usually some diagonal line that as we let x values get really big or really small, the curve will generally go to get closer and closer to that line. So those are the three types of asymptotes, and we have some tools in order to find the vertical, the horizontal, and the oblique. So the first thing that I want to do with any problem is I want to factor it if I can. So this top part is x cubed minus 8, and that can be written as a difference of cubes. So that can be written as x cubed minus 2 cubed. And we have a formula for that. And it says that if I have some value cubed or variable and minus another value or variable cubed, that I can rewrite it as the first minus the second. And that's going to be times the first squared minus the, plus the first times the second plus the second squared. So this is just a formula that's called the difference of cubes. And if I notice that this follows that difference of cubes, my a here is x and my b is 2. So I'm just going to replace a with x and b with 2. And I should get on the top of this function x minus 2 times x squared minus 2, plus, oh, let's get that mixed up, plus 2x plus 4. That's b squared. That's 2 squared, which is 4. So that's going to be the top of my function there. And then on the bottom, this can be just factored as x minus 2 times x minus 1. And that's just using some factoring methods there, like breaking it apart, and see which two numbers when multiplied together give me the 2 and which two numbers when added together give me the negative 3. And it doesn't take too long to figure out that the only choice is negative 1 and negative 2. All right, so now that I have that, I can see that these two factors here are going to cancel out. So that's what I'm going to do. That means that I have a removable whole at x is equal to 2. So wherever 2 is, I go up or down to see where that point is on my curve. And I'm going to put a little circle there because there's a hole there because we were able to factor out the factor there. All right, so now that I have this, makes it a little bit easier when I'm trying to figure out what my asymptotes are. So my vertical asymptotes are anything that's going to make the bottom equal to 0. So I just set the bottom equal to 0, and then I'm going to go ahead and x is equal to 1. Now I want to check one thing first. I need to make sure that on the top, when I plug this 1 in, that I do not get a 0, because if I do, then I have a 0 over a 0, and that usually tells me, well, it's an indeterminate form, and it tells me that I can usually factor something out. Not always, but most of the time. So if I put a 1 in here, I get 1 plus 2 plus 4, and that's definitely not equal to 0, so we're fine. So if we get a non-zero over a 0, that tells us that this value here is going to be a vertical asymptote. So this is the vertical asymptote. So if we have a graph like this, we have the x value 1. We're going to have an imaginary line here where this graph is going to approach it at some point. All right, the next thing it says is find the horizontal asymptotes. So when we have a polynomial over a polynomial, we have one of three scenarios. Either the largest exponent is on the top, like it is in this case, the largest exponent is on the bottom, which is not this case, or the largest exponents of these two functions are the same. And we'll go through the other options later, but right now the largest exponent is on the top, and whenever that's the case, then the function is increasing at a much faster rate on the top than it is the bottom. So as I let x approach numbers like positive infinity and negative infinity, this value is getting infinitely larger, infinitely small. Therefore, I have no horizontal asymptote. So long story short, if my highest exponent of both polynomials is on the top of the function, then I have no horizontal asymptotes. If it's on the bottom, I have a horizontal asymptote at y equals 0. And if they're the same, then I look at the ratio of the two leading coefficients. So for example, if they were both 3, it would be 1 over 1, which is just 1. All right. So no horizontal asymptotes. All right. And then the last one is the oblique asymptote. And it's kind of a pain. We have to be able to use long division. And what we're going to do is, and I can use this bottom one here because it'll make it a little bit quicker, or it should. But what I'm going to do is, remember, it's the top divided by the bottom, so I'm going to put that in long division form. So x minus 1 divided into x squared plus 2x plus 4. And what I'm looking for that asymptote is really just these first two values here, these first two terms. So x goes into x squared x times x is x squared, x times negative 1 is negative x, and then I'm going to subtract these. So x squared minus x squared is 0. 2x minus a negative x is going to be 3x. Easy to get confused there. Remember, we're subtracting. And minus a negative value is plus that value. So now I bring down the 4, and I see x goes into 3x 3 times. So it's going to be plus 3. 3 times x is 3x. 3 times negative 1 is minus 3. Subtract those, and that's going to cancel out there. And 4 minus a negative 3 is 7. So really I have a remainder here of 7 all over x minus 1. But I can ignore the remainder. So all I care about is not the remainder part of this expression. So x plus 3. So y equals x plus 3 is going to be our oblique asymptote. So if I go up 1, 2, 3, that's a 1 over 1. So you're going to have some kind of line like this. So maybe it approaches like this. It's something you're going to have to put in the graph, but at this point, all we're looking for is those asymptotes. All right. If you have any questions, let me know, and I hope you have a great rest of your week. Thanks.